Okay, this is a problem just like all the rest, except we don't know the mass. Where the mass should be, there's the word spam. Okay, so what you do for these is you just leave the m there. You do what you normally would do. So we're going to find the parallel force, right? Right, it's mg sine theta, and we'll have to leave it in terms of m and hope that it cancels out, which it will if there's no like external applied force that doesn't have m in it. Okay, so now let's just set this up. It's going to be m times 9.81 times sine of 35. Okay, so there we go. So let's crank that out here. Okay, so I'm just going to do 9.81 times sine 35, and I'm going to store that in A. And I get that the force parallel is equal to m times 5.6268. Okay, so that's the force acting down the plane. 5.6268 m. Okay, we just leave it in terms of m. Okay, and let's see what happens. Okay, so now we set up our thing. If it's a frictionless plane, this is the only force acting on it, right? And so up the plane is positive, down the plane is negative. So this is negative, right? And our sum of our forces is negative 5.6268 m equals m times a. Well, this is pretty simple, right? I can cancel the m's, and this is what happens. It'll either happen and it's solvable, or it won't happen. That is, if you have a term over here that doesn't have m in it, and then it can't be solved, right? And so we get that our acceleration is negative 5.6268 meters per second squared, right? And that negative means that it's, of course, going to accelerate down the plane. Now, we could shove it up the plane, and it would slow down and stop. It would accelerate down the plane since it's a frictionless plane, always at the same rate, okay? So that's kind of cool.